Continuando con las ponencias, la ponente de hoy, la doctora Carolina Oliveira, es una profesional de renombre internacional quien tocará un tema crítico y actual relacionado con la biodiversidad y la mitigación del cambio climático. El tema que nos compartirá el día de hoy es Tendencias de la biodiversidad en diferentes escenarios de mitigación con un modelo nacional de evaluación integrada. Jocelyn, por favor, coméntanos sobre su experiencia de la doctora Ana Oliveira.
Claro que sí, she is a postdoctoral research in energy planning program PPE, COPPE, UFRJ, as Energy Lab. She has a BS in Biology 2008, Bio UFRJ, and she also has an MS in Environmental and Energy Planning 2012, COPPE, UFRJ, and has an exceptional PhD in interdisciplinary in ecology 2018 in University of Área. Her main interests are climate change and biodiversity conservation. Her master's thesis focused on degraded forests and REDD+, and her doctoral research on compliance with the Resilient Forest Code and the impacts of a payment for environmental service in Atlantic forests. She was a consultant for Center for International Forestry Research, CIFOR. Currently, she works with Synergia Forward Team on several projects and contributes to the incorporation for terrestrial biodiversity in integrated assessment modeling. Now that we know more about our speaker's experience and achievements, we invite you to listen carefully to her presentation that she will be giving. Further promotion, postdoctoral Carolina, you already have that permission to share. You can start.
Hola, ¿cómo están? Am I sharing the right screen? Oh, no.
Yes.
Now I am, I guess, right? Can you see properly?
Yes, visualize.
Hello, how are you? Thank you all for the invite. You're checking my screen, right? My screen here. Can you see?
Yes, it's right.
Oh, great. So, sorry for speaking English. I know most of you were speaking Spanish. It's just harder for me to speak Spanish, so I can understand you, but I cannot properly speak. So you probably will understand me better in English. And you might be asking what a Brazilian is doing in a Peruvian Congress about biodiversity and resources in Peru. But I think I was invited because my last research that was about investigating biodiversity trends in different mitigation scenarios in a national integrated model. It was published in Integrated Environment Science this year, actually. And then we'll be talking about this, but I will do a general context about IAMs too, so you can understand the research and maybe apply the same methodology that we did there here in Peru. Maybe somebody would like to collaborate and apply. So I'll be speaking in the name of my group, that's Synergia, Center of Energy and Environment Economics. It's in Rio, Brazil, within the Federal University of Rio de Janeiro, right? So I'm jumping a few slides because of time issues. So we are 5 professors, 7 postdocs, more or less 20 PhDs and 2 master's students. And the lab professors are Roberto, widely known because of his participations in IPCC, and Alexandre, André, Pedro, and Joana. Some of the slides I'm presenting are from them, so I'll be just letting you know. So we are a lab that have been recognized in terms of academia, but I'll jump this introduction. What we do is actually modeling. With a big chunk of our work nowadays is related with modeling. So we have 3 3 IAMs, integrated assessment models, and 6 satellite models, right? So I'll be presenting today one mostly, that is the National Energy and Land Use Model called BLUES. So in terms of IAMs timeline in our lab, we started developing IAMs since 2003. And in 2011, there were 300 technologies. In 2013, there were more than 8,000. We helped Peru to develop the Times Peru, that is now part of the energy planning framework of Peru, that is used by the Peruvian Minister of Energy and Mines. And nowadays, we have an international model called COFFEE that is used in PCC framework. And BLUES was developed in a thesis in 2017. Since then, it has been evolving. And nowadays, we have a second version of BLUES. Elena is a national IAM that we helped to develop in Ecuador. So we are the only South country that has IAM that is using the IPCC. So that's why we talk a lot about IAMs in general. But what are IAMs? They are simplified representation of complex physical and social systems focused on the interaction between economy, society, and the environment, right? So when you do a sectoral model, for example, you're thinking about energy, and then you want to optimize energy, and then you don't necessarily think how this will impact land use and how this will impact water. So here, when you increase the energy demand, you necessarily, depending on the energy optimization, increase water demand and material demand. So this all interacts and results in one unified optimization. So IAMs constitute up to 6% nowadays of IPCC report content, but 25% of the summary of policymakers. And then they are the best part of the coverage. So you can see in the evolutions of the IPCC reports, how much is represented in terms of articles and how much is the percentage of the summary for policymakers, right? So we are in R6 now, that was released last year. And how much of IAMs is part of the climate literature in general. So they represent a smaller chunk of the literature, but a high level of release conference, right? Press release. So IAMs emerged in the 70s as a response to the need for comprehensive analysis of complex systems. They evolved more, so from energy, they start involving more sectors, technology advantage, and they now become essential tools for policymakers and researchers to assess long-term impact of policy in different scenarios. So understand the implementation impact of a policy and how this would impact in long-term. So the introduction of climate change as a global concern led to the incorporation of environment aspects in the IAMs, and now they are widely used for the climate society. I don't know why it's not so. IAMs, like I said, I used to explore various scenarios and policy options to address climate change and sustainable development goals. IAMs also help policymakers make informed decisions by providing insights into economical, social, and environment trade-off of policy options. So we have a wide set of options, how each option would result in terms of energy use, land use, water use. They give this kind of answers. Some applications of IAMs include energy sectors, where IAMs play a critical role in analyzing energy demand and supply, as well as the impact of climate and energy policy. IAMs also help to inform climate change mitigations once they inform the optimal mitigation. And nowadays, they are being incorporated in the objectives of sustainable development to understand how this could be achieved together with climate mitigation. Some of limitations of IAMs include that IAMs rely on a number of assumptions on uncertain data, limiting their accuracy and predictive power. IAMs are also very complex models that often have to oversimplify some parts of it, of reality and some relationships, so they can properly run. And there are some ethical concerns about how to balance short-term economic interests with long-term social and environmental sustainability. Once you have to tell the model what you have to prioritize and what you have to optimize based on. But like in any model conference, you would hear all models around, but some are useful, and people should use models as a drone, use as a lamppost for support rather than for illumination. So with this in mind, I'm gonna start showing you guys our modeling platforms. We have three main IAMs. One is economic global model. Another one is IAM related with optimization in term that has the same size, so 18 areas like this, so they communicate. And then we have information for our national IAM. So the TIM gives global economic impact, while the coffee gives global results in terms of energy, land use, and emissions. And within this research, within this, we know what's the Brazilian budget, so we can run our national model and have national results in terms of energy, land, and emissions. Like I said, the T has the same 18 region as coffee, and it brings the evolution of the global economy until 2100. So it gives optimization options until 2100. The same for coffee, and both are hard linked. So that means that when you change a land energy system, it changes also the land system requirements. So the connections are strong, so hard linked. And then it was the first development in a thesis by the Professor Pedro Rochedo. And Blues is a more recent model. It has a demand side that is more technology detailed for Brazilian types of technologies. So it focuses on Brazil, and instead of having Brazil as one region and a global model it has Brazil as 5 regions, and also gives a result of Brazil as a region within itself. So 6 regions that you can reply results on. And it's these terms maybe most of you don't know, so I'll jump a little bit ahead. So some of the Blues applications are I'm giving this example of this paper published by Pedro Rochedo as a main author. And he was investigating how the exchange for political support that Brazil was giving to the ruralistas, that the people related to the to rural property, big properties in Brazil that have a lot of money, they asked, so in exchange for Brazilian support, Brazil was decreasing some laws, and in consequence, it was decreasing deforestation in Brazil. So they're lowering environment licensing requirements, suspending the ratification of indigenous lands, reducing the size of protecting areas to inform society how this would impact in terms of climate policy. Pedro led these articles and tried to understand in a scenario that the world would stay under 2 degrees, how this change in the governance in Brazil would change our way to achieve our Paris Agreement's goals, right? So it ran 3 scenarios. in terms of deforestation, one with weak governance, so higher deforestation, one with intermediate governance, so intermediate deforestation, one with strong governance, so lower deforestation. And this is how they reflect in terms of Amazonian and in terms of Cerrado. So in terms of numbers, we're thinking about 27,000 kilometers a year in the Amazon in 2030. That's like almost a third of area of Austria, right? Just giving you a context. And this is the Cerrado biome. So the Cerrado biome also has a strong, an intermediate, and a low, a strong governance, intermediate governance, and a weak governance. In terms of deforestation, it reflects in more deforestation for the weak, right? And what it showed is, okay, Brazil has a carbon budget if we think we want to achieve the 2 degrees, right? So how would this reflect in our national targets, in our national action? So if we have deforestation in the weak scenario, in the strong governance, we're going to have this amount of carbon emissions associated with deforestation. And all this amount of carbon can be released by other sectors, for example, oil extraction, transportation, and so on. If we have intermediate governance, you can all see that deforestation increased the emissions within our carbon budget, and the remaining one for other sectors reduces. And the strong one, there is almost the weak governance and strong deforestation, there is almost no carbon budget left for the other industry. And also the relative costs to achieve our carbon budget increases. And nowadays we're thinking more and more how IAMs can help to understand how we can achieve the Sustainable Development Goals. In Blues, we started to investigate, incorporate the SDGs in our analysis. Actually, we start with a Peruvian, Evelyn, that she tried to incorporate the water problem within Blues. So now Blues has outcomes in terms of water, and also analyze water management, infrastructure investment, how carbon tax and costs would affect the carbon use within the same framework. So we can establish, for example, that you only have a certain amount of water, and it can optimize considering that, and it changes the optimal options, like foreseen. The same has happened for our pollutants. It has, I will jump a little bit because of time. So how to incorporate biodiversity, right? Biodiversity is goal 15 in terms of life on land, goal 14 in terms of on the ocean. We are thinking more on land, so we're thinking more about the goal 15 of the social development goals. It aims to protect, restore, and promote sustainable use of terrestrial ecosystems. It recognizes that the human environment and climates are intertwined and interconnected. When you think about one, it's impossible not to think about the others. So an impact that you have in either systems, you impact the others with a cascading effect. So it recognizes this dependence. Also, climate change and biodiversity historically have been seen separately, and now more and more it is recognized that they have to be seen together and fought together. Both problems have been being addressed in the same framework. Once, like in 2021, even if PPS, that is the Finance for Biodiversity, Ecosystem and Service, and the IPCC, that is the International Panel of Climate Change, they joined to do a workshop on climate change and biodiversity. And when they did that, they show that mutual reinforcing of climate change and biodiversity loss means that satisfactory resolution of either issues require consideration of others. Policies that simultaneously address synergy between mitigation, biodiversity loss, and climate change, while also consider societal impacts, offer the opportunity to maximize co-benefits and help meet developing aspirations for all. Right? And so it's important to think. Some examples here of how climate change impacts biodiversity. For example, these are the percentage of animals and seagrasses exposed to potential dangers under different temperatures. So the color means higher temperature projections. So if 1 degree, remember 1.5, remember that we are already 1.1, so many species are already being lost due to climate change. So with 1.1, this amount of species are lost. And then with 4 degrees projection, that's the worst projections we have more or less nowadays, much more species are lost. Actually, some areas represent loss of all species, right? So it's very dangerous to think about this because it represents a change, completely change in some ecosystems. In terms of EPCC, I want to also to highlight the different impacts in terms of terrestrial, freshwater, and ocean ecosystem change. And then it shows that Central and America and South America, where both of us are, have high or very high impact on these systems, right? And also related to biodiversity loss, we have that while the temperature is rising, you have more and more species being lost. The tree mortality also increased, the wildfires, as we have been seeing, also increase. And all these drive carbon loss, structure change, and so on. I don't know how familiar you guys are with this type of graph, so I'm gonna go a little bit slower to understand. These graphs are traditionally projected with a lot of IAMs together projections. So we have many IAMs driving their results, and then you have a range of options within them. So if you check here, this is what's in gray is all climate categories. What is in this pinkish is what is in, if every country implements their national contributions or what they said to UNFCCC, they committed to do, that's the range that we would have in terms of reduction in CO2. So we are seeing this graph in gigaton of CO2 equivalent per year. And this counts for all greenhouse gas emissions. And this only counts for carbon because the protection is a little bit different. And that's why you guys saw in the probably last year in the news, talking about also having a target for methane and other greenhouse gases, right? So because of that, you can see that to achieve 1.5, that's the blue, or even 2 degrees, we have to have a steep reduction in our emissions and achieve net zero between 2060 or 2080, depending if you're considering only CO2 or all greenhouse gases, right? So we have to act fast to reduce our emissions. Here, I just want to show that in terms of potential of net emissions reduction until 2030, these past emissions, we have all the sectors, but I will focus on the AFOLU sector. That is the most interesting for me, that deals with biodiversity. So the AFOLU sector has a wide potential of reduction. emission reduction is one of the sectors that when you consider carbon dioxide removals that they're necessary nowadays to achieve 1.5 degrees, you have to consider the AFOLU sector, right? So some mitigation options related with AFOLU sectors is carbon sequestration in agriculture, reduction of methane and how to say that in English, emissions in agriculture, actual reduction in conversion of forests and other ecosystems. So this directly impact biodiversity, right? If you reduce the conversion and the loss of ecosystems, and I also have to do ecosystems restoration, afforestation and reforestation, improve sustainable forest management, reduce forest food loss and food waste, and shift to balanced, sustainable, and healthy diets. Always when you consider options, you always end up talking about diets, exactly because all systems are connected. So if you eat more meat, for example, that require more energy and more land to grow than equivalent protein of vegetable source, that would reflect in more emissions in the end. So in the summary of in relation to biodiversity and climate change, the mutual reinforcement of climate change and biodiversity laws means that satisfactory resolutions of either needs consideration of others. Previous policies have largely tackled the problem of climate change and biodiversity separately, and now policies are starting to recognize the importance of see them together to an immediate and sustained effort is needed. We have to act now and keep acting to address both problems of Anthropocene. But how to incorporate biodiversity in blues within the IAM framework that I'll be talking about? So blues is IAM that has an energy system, a land system. It deals with building, transportation for passengers and for things, and also have 11 industries represented and waste and residues. So all things are interconnected. So when you have an increase in any demand in terms of industry or transportation, you increase the land and energy requirements, right? So what we did is testing 3 scenarios. One, we called reference scenario, considering only current policies. Another one that is called NDC, that is a world where Brazil fulfills its national contributions to achieve Paris Agreement, and one that Brazil would stay within its budgets, considering a world that would achieve 1.5 degrees. In terms of EIM projections, so we use a post-processing analysis to see the biodiversity impacts, but in terms of the results of IAMs for these 3 scenarios for blues IAM, these were the results in terms of emissions. So you have in the reference scenario, a lot of emissions, a little bit increasing. In the NDC scenarios, we decrease considerably the emissions, achieving net zero in 2050. But if Brazil needs to fulfill its role, let's say like this, in a world that achieves the 1.c limits climate change to 1.5 degrees, it would be necessary to Brazil to consider reduce and even remove some carbon from the atmosphere, right? So anything that is under 0 means carbon removal, net removal. So we are going to be planting more forests, for example, than emitting carbon. So how we thought the link between biodiversity and blues. So as I presented blues, we have blues-based maps for land use that we're going to use this to cut our data sets in terms of biodiversity, because it's very hard to think how to incorporate biodiversity within such a big model because of limitations. For example, like I said, blues has only 5 regions, right? So the the difficult here is biodiversity is not, so the scale is very different. When you think about ecology and think about ecology modeling, you think about very small scale most times, or very big computational capacity. So you can deal with a lot of computational power within this. But to relate both and to be able to run properly the models, we decided to do first tests as a post-processing. So we use the results as the blues within the land use classes of blues. So this is what is behind blues in terms of land use. So we have 14 regions of land use classes. So from water, urban, pasture, that is divided in health pasture and degraded pasture, savanna, forest, also savanna and forest when they are protected. So because there's difference in terms of how much deforestation they get. And also we have a cost category or a proxy where would be cheaper to produce in terms of agriculture outcome, really. So it considers the distance to roads, it considers the soil itself, so, and some other patterns of how could the product get from here to the ports, whatever it is. In terms of biodiversity, we chose the biodiversity indicators that were already well established in the literature. So we didn't create new indicators. We used what was available for the whole world. So if you have a IAM in Peru that you guys have, you could simply replicate our methodology. So what we chose was indices that is called Biodiversity Intactness Index. Another one that is called a human footprint. So here it's this indices, the biodiversity intactness indices says how much a pixel is intact in relation to what is believed to be its original biodiversity. And here is the opposite. It says what's the footprint of a human in 1 pixel. And we also use a richness, that means number of species in each pixel, richness index, but we normalize by the human footprint to consider how this would be in each pixel, so we could actually communicate. So in terms of results, no, I think I'll jump this one because of time. In terms of those results, we have the projections in terms of forests. So it's important to say that we use the intermediate scenario, deforestation scenario of the previous article I mentioned, because we wanted to consider both periods when deforestation are growing and when deforestation is being reduced. So in average, we established the intermediate one as to be used. And then we see forest loss in the reference scenario, right? And then we also see the increase of degraded pasture here. And the indices scenario, Brazil committed to conserve most of this forest and actually increase reforestation. So that's why you see reflected here less forest lost than in the other scenarios, right? And then because of that, you have less degraded pasture being showed up. And in the 1.5 scenario, you see that this requirement for the forest to increase. So we have more and more forest area and savanna area in terms, so we can achieve the 1.5 degree commitment. In terms of accumulation of land use change, we have 0 here, so everybody can understand. So anything that's above 0 is increasing. It's over time, its representation. So we have pasture increasing in the reference scenario and forest decreasing. And in the 1.5 sphere, we have forest increasing and pasture decreasing. So how we relate this to the biodiversity? We get all these results for blues that comes as a result from the IAMs. And within then, we created biodiversity index with the same cut that blues has. Blues has 14 land use classes, 7 cost categories, like I showed you, and 5 Brazilian regions. That give us 490 statistical parameters that we use them to create these indices. And we consider this index fixed. That means for a pasture, you may have one index, one parameter associated with a pasture in a type A category in the south. And then we have a different index in a pasture in type B in the northeast region, for example. But what it showed is that all the biodiversity trends, independent of the index we use, show that the reference is losing more biodiversity than the C scenario is losing still losing some biodiversity, and the 1.5 scenario would be increasing in some biodiversity. But then we thought, okay, increasing biodiversity, depending on the indicator of biodiversity used, may be confusing because some biodiversity is lost, is never going to be regained, right? So, for example, one species that is lost, it's impossible to be regained, even if you do a lot of restoration efforts. So we consider a sensitivity analysis where one is the all land uses together. 2 is only natural land clover, so only savanna and forest in our land cover classes, right? And 3, we only once the savanna is lost or the forest is lost, it never regains. So you see the difference that in 2 for the 1.5, you would be increasing the biodiversity because of forest restoration. But in reality, if you only consider the loss of biodiversity, even in 1.5 degrees, you would be losing quite a bit of biodiversity. So the truth, if you can say, relies within something between both. But it's important to point out that the choices of methodology reflect a lot on the biodiversity index, right? So the highlights is that a post-processing analysis to investigate biodiversity trends, we performed 3 mitigation scenarios using a national IAM. Different mitigations were used, but they show the same trends, and Brazil can align its biodiversity and climate goals through nature-based solutions. That means that Brazil can conserve, restore, improve agricultural practice, like the interactions between forests and using agroforest, for example, and increasing using forest within the crops planting. So what do this say about Brazil? Brazil, in terms of emission, and in terms of forest loss, this is forest loss in Brazil, this is emissions in Brazil. So it reflects a lot the forest loss pattern in Brazil. So if you interpolate here, the deforestation graph, it's very similar, measured with this trend, right? Because forest land use change is a big chunk of our emissions. Brazil actually lost in 2020, 23% of world's primary forests occurred in Brazil. I found a comparison to Peru, and Peru is responsible for 4% of the 2020 lost in terms of world primary forest. Peru also has a very important pattern of emissions related with land use change, because it has lost a lot of forests since 2013 until nowadays. So you can see that we all all face the deforestation problem. And we have to consider how to think together in terms of climate and biodiversity. The main way to do that, no doubt, is conserving forests and conserving our ecosystems that are going to keep both biodiversity and the carbon in the ground. The main takeaways that I wanted to highlight are that IAMs are useful tools for policy making. They are very valuable, offer very valuable insights into the costs and benefits of different policies and targets. IAMs can also be used to explore the interaction between climate policies and other development goals that, as we saw in the case of water, pollution, and now biodiversity, helping us to maximize benefits and minimize unintentional consequence. For example, in our analysis, we found that bioenergy in the northeast of Brazil, the projections to achieve 1.5 scenario could create a competition between biodiversity conservation and bioenergy within the northeast. So when you see both together, you see this kind of consequence, and you can think about policies that have to deal with this. In Brazil, climate and biodiversity policies should be strongly aligned so that we can achieve the Paris Agreement. Climate mitigation requires forest conservation and restoration in any area in the world, and it's possible to replicate the methodology we use in Brazil for a Peruvian IAM. So I left some time for you guys to give, ask some questions, but thank you so much for listening to me, and I'm here, and this is the contact from the lab and my contact if in case you want to send me an email with doubts too. So do we have any question?
We are really pleased for your presentation, postdoctoral Ana, Carolina. Now we all can ask questions from whatever platform you are on, via chat or audio. While we wait for the questions to come in, we move on to the questions to the forum. The first question is, what are the future research areas or additional data needs that could further enhance that understanding of biodiversity trends under mitigation scenarios?
Can you repeat, please?
Yes, of course. What are the future research areas or additional data that could further enhance the understanding of biodiversity trends under mitigation scenarios?
Oh, there is a lot of data missing, mostly because the time of collecting data for biodiversity study is very different from the time of collecting data for climate. Once most of the data is related with technologies and we can collect from the ground, while biodiversity data takes years to you to see the health of a community, of a population. So the major issue is how to think ways to put both in the same scale. So collect data in a scale that can be used and interpreted by climate policy. For example, how can we, I don't know why I cannot come back to the screen that I can see you all, I'm sorry. I'm trying to do that. So how can we have data that allows to understand the different aspects of biodiversity, right? Because you have functional biodiversity, genetic biodiversity, and then beta biodiversity, gamma biodiversity. When you talk about biodiversity, you discuss all these different types and issues related with biodiversity. We don't even know which ones are the best to deal with the climate, to communicate with the climate policy. So is extinction rate better? Which indicators would be better? How can we communicate with the public both policies? How can we address policies thinking about the biodiversity indicators? So yeah, there is a lot of data missing. So, and especially how to put the data in the same scale too. Even when we have data, they are not in the same scale.
Okay, it seems that there are no more questions, and we thank you for your presentation, for your contribution, and we hope that this presentation will be not the last time, and we will have the pleasure to count on you on your expertise. Thank you so much.
Thank you
Yeah.
so much.